Okay, let's look at a new type of problem. Example 5, we're still dividing our radical expressions, but we have a different situation here. We want to simplify the cube root of 7x over the cube root of 5y squared. If I look at this problem, I cannot simplify the cube root of 7 or the cube root of x or the cube root of 5 or the cube root of y squared. Even if I put this together into one giant cube root, like we did up here with example 4b, 7 over 5 doesn't help me, x over y squared, that doesn't help me at all. Totally different situation here. Now, if you think back to geometry, when you were dealing with those special right triangles, you had to rationalize the denominator all the time. When you, if you remember, we couldn't have a denominator, or we couldn't have a radical in our denominator in our final answer. But it's the same idea here. We don't want to have a radical in our denominator, but now we need to rationalize our denominator when we have a cube root instead. I'm going to come over here real quick just so you kind of remember how our rationalizing the denominator process works. If you have 1 over the square root of 2, for example, we don't like that there's a square root of 2 in the denominator. So to get rid of it, we multiplied by the square root of 2 over the square root of 2. And remember, the reason that we can do that is that anything over itself is really 1. We're really just multiplying by 1. We're not changing our problem at all. Square root of 2 times the square root of 2 would be the square root of 4, or 2. We have that same process going on here. We need to figure out how to get rid of our radical denominator. So what I like to do is see, okay, I have a 5 to the first power here. In order to be able to cube root it, I need to have 5 to the third power. So I need to multiply by a 5 squared, because then 5 to the first, 5 squared would give me 5 to the third. I can cube root that. Then look at the y squared. I already have y squared. I want to have y cubed so that I can cube root it. I need to multiply by another y here. Make sure we're multiplying by the same thing on the top. Multiply by the cube root of 5 squared y. And we could write that as 25 instead. I'm just going to leave it as 5 squared though, for now. Because when I get to the bottom here, cube root of 5y squared times the cube root of 5 squared y. Since our index is the same, we can multiply. 5 times 5 squared would be 5 cubed. Y squared times y is y cubed. And then in our numerator, 7 times 5 squared and then x times y. Then our denominator again, cube root of 5 cubed y cubed. Well, the cube root of 5 cubed is 5. Cube root of y cubed is y. And it's cube root, odd roots, no absolute value. All right, up here, we have cube root 5 squared times 7 is 175 xy. Last thing to check, we can't cube root the x, we can't cube root the y. Let's see if we can simplify that cube root of 175 at all. And check and see if there are any perfect cubes that go into 175. Well, I know 8 is a perfect cube because 8 is 2 to the third power. 3 to the third power is 27. 4 to the third power is 64. 5 to the third power is 125, so that's not going to go into. This is our final answer without a radical in the denominator.